This is the problem or the structure that we are going to solve today. We have this triangular truss. The length of each side of this triangle is 10. It's an equilateral triangle, so it has all its sides at the same length. Okay, so this is 10, 10, and the angle is always 60. All the angles are the same, 60, 60. We have a pin here, or a hinge here, so that's why we have two reactions in the X, in the Y, and we have a roller here, and we only have one reaction. And we have two forces. This is 12. You will have different numbers. This is 12. This is 10. And now we have to apply the equations. So what's the vertical equilibrium? Here we have all the forces that go up, and here we have the forces that go down. I have assumed these directions. It can change. If we have a negative value, then that means that the arrow should face the other way around. So what goes up in this case is AY plus DY. AY plus DY. These two forces go up. What is going down? 10. So these two forces going up equals 10. Now look at this. This doesn't make any sense, but I'm going to do it anyway. And so I have assumed that AX goes right. And this force 12 goes right too. Okay, so AX plus 12, both go rightwards, equals what? It doesn't make sense, so we don't have anything going left. So that equals 0. Yeah, it doesn't make sense, but it makes sense if we change the sign. So if we say that AX equals negative 12, now the value of AX is negative 12. So that means that our assumption was wrong. It's not because we have a negative value. So that means that we have to change the direction of this force. Okay, doesn't matter. We change the direction. And now that we have the right direction, AX equals 12. It's not negative anymore. It's 12 in this direction. So we can say that AX equals 12 with the right direction. If we have any other negative number, we will have to change the direction that we have assumed. Because, okay, so this is what the equations are telling us. And now that equation would be AX equals 12. What about the vertical? The vertical, we have this. We don't have a y, we don't have dy, so we can't solve this equation. So we have to go to the moment equation. So what's the moment equation? It's not working. So the moment equation is whatever goes clockwise equals whatever it goes counterclockwise. Okay, so let's analyze, and we're going to take this point as a point of rotation. So we take this pin, and we have to look at the effect of all the external forces. What are the external forces? 12, 10, and dy. Okay, so let's look at the effect of 12 on that structure. I can draw an arch. So if this is the center of rotation and this is the point at which 12 is applied, if I move, that's the natural movement. So that will go in this case clockwise. Okay, what about the effect of 10? About this point, about A. If I'm going to draw another arch, that's the center. That's the point. So what does it happen when we apply this force down? If we apply this force down, this rotates in this direction too. So this is both forces, 12 and 10, move the structure clockwise. What about dy? Okay, so we can draw another arc about this point. What's the effect of d? We move it upwards. Okay, so what's the effect of this? It goes counterclockwise. So I'm going to put this in a different color. So the clockwise rotations is because of this force, 12, because of this force, 10, and the counterclockwise is because of the dy. So what's the moment here? So the moment is always clockwise equals counterclockwise. Okay, so that's the this is what we have to do now. So what goes clockwise? Clockwise is this force 12 times the distance, but the distance is the perpendicular distance between point A and the line in which this force is applied. So this force is applied here. So this distance is 8.66. You can measure or you can calculate the height of this triangle, but if this is 10, this will be 8.66. So what's the moment of this force about this point? It's 12 times the distance, 8.66. So that would be 12 times 8.66. What else? We have the effect of 10 because it's clockwise. So that will be 10 plus 10 times. And what's the distance? This is the force. This is the line in which the force is applied. So the distance is the perpendicular distance between this point, point A, and the line of application of this force. So in this case, if we measure this, this is 15. Or the other way to do that, we know that this is 10. So if we divide this by half, this number here would be 5, this distance. Is 5. Okay, so 10 plus 5 is 15. So the distance of this force between the force, the line of application of the force, and point A is 15. So I have to multiply this times 15. So this is clockwise. What do we have counterclockwise? It's dy times the distance. So what's the distance? 10 plus 10 is 20. So that will be dy times 20. Okay, if we want to put this in a different way, okay, what we have clockwise equals what we have counterclockwise. So counterclockwise, dy times 20. Clockwise, 12 plus 8.6, 10 times 15. Okay, so with this, I think we can calculate dy. So dy will be 12 plus this, the calculator, 12 times 8.66 equals this plus 10 times 15, 150. And now I have to divide this by 20. Divide by 20. So this is 12.69. dy equals 12.69. Okay, so now we have ax and dy. dy, it's positive. Okay, perfect. That means that this is the right direction. So I have assumed the right direction for dy. What about in the vertical? Okay, so now ay plus 12.69 equals 10. Okay, that means that this goes to the other side of the equation as a negative number. So ay equals 10 minus 12.69. This is 10. So that means that ay equals negative 2.69. There you go. So it's negative. It doesn't matter. Well, it matters because we assume that this direction is wrong. So if you don't want to deal with negative numbers, rotate this one. So that goes down. And if it goes down, okay, so it's not negative 2.69, it's 2.69, not negative. It's 2.69 going down. So if we have a negative result, means that the direction that we have assumed is wrong. Okay, so change direction and type a positive number. So those are the reactions. And dy equals this 12.69. There you go. So those are the reactions here. So now we have to start solving the equilibrium at different points. Okay, so we're going to start a point D. So I want to select this. I know the angle. And I'm going to start with point D. In point D, I know that I have a line going up, and this line is 12.69. I'm going to draw this line with the right. It's 12.69. This is the right dimension. And it goes up. Okay, so that value is 12.69. 12.69 going up. And now we have this bar, and I'm going to name it. We have this bar and that one. So this one is DC. And this one is DE. So now we can assume the direction of this. Let's have Reno decide. Okay, so in this case, it goes in this direction, and in this case, it goes in that direction. I think it's correct, but it could be the other way around, okay? So we are assuming these two directions. This goes down, and this goes left. Okay, so now equilibrium in these points. So I'm going to copy the vertical, and the horizontal. Here. Here. So what's the vertical equilibrium? We have 60. This DC has a vertical component. And DC has a horizontal component. So the horizontal component is in this direction. So I select this one. I change this to horizontal. And I want an arrowhead here. There you go. I'm going to move it slightly so that you can see that we have this horizontal component there. Okay, so we have a horizontal component. We have DE going, in this case, left, and we have the horizontal component of DC going right. Okay, so for the vertical, how much is the vertical component of DC? It's DC. If it's vertical, it's always sine 60. And what's the horizontal component, this red line? It's DC cosine 60. Okay, so DC sine 60 is the vertical, DC cosine 60 is the horizontal. So in vertical, what goes up? 12.69 equals what goes down? DC sine 60. Horizontal, DE, it goes left, equals DC cosine 60 and that goes right. Okay, so here we can solve DC equals sine 60 divided by 12.69. Okay, so let's do it. 60 trigonometry sine 60 is 0.86 divided by 12.69. It's 0.068. Well, it's quite 68. Sorry, it's the other way around. It's 12.69 divided by 0.60. Okay, sorry. It was 12.69 divided by 0.86. And that makes more sense. So it's 14.75. It's 14 75. Now, how much is it? DE. DE is 14.75 cosine 60. Cosine 60. Cosine 60, I think it's going to be half, say 60, trigonometry, cosine, it's 0.5 times 14.75. This is 7.37. So TE is it 7.37? Yeah, 7.37. So that's TE. Okay. As always, we can do this graphically. So if I select this curve, and copy this thing here, then I have a line, a horizontal line going this way, and then I have this tilted line going this way. Look. Now I trim this. And if I take dimensions of this dimension line, this is dy 12.69. This is 7.33. And this is 14.65. Okay, so it's 14.75, here it's 6.5, kind of, and this is 7.3, 7.3. This is 12.69. The next step is, now we have this point. The next step, I will analyze point C, but that will be in the following video.